Okay, this next question. A car slows down from 28 meters per second to a stop at a rate of 3 meters per second every second. How far does the car travel while stopping, and how long does it take for the car to stop? Okay, so the givens. Well, a car slows down from 28 meters per second. That's the initial velocity. So when you meet the problem, high problem, the car is traveling at 28 meters per second. It slows down to a stop at a rate of 3 meters per second every second. It slows down to a stop at a rate of 3 meters per second every second. What's the final velocity? Stopped or the 3 meters per second? It slows down to a stop. So in the end, it stopped. Its final velocity is 0. It does that at a rate of 3 meters per second every second. What is 3 meters per second every second? 3 meters per second every second is the acceleration. That would be positive or negative. Well, how do you go from positive 28? I arbitrarily made this initial velocity positive. I could have made it negative, but I made it positive. How do you go from positive 28 to 0? And change by 3 meters per second every second. Well, you have to subtract it. So your acceleration would be negative 3. So every second, this goes down by negative 3. So it's going to go down from 28 to 25 to 22 to 19, subtracting 3 each time until it stops. That's the acceleration. The acceleration must be negative because we're going from 28 down. And it says it's 3 meters per second every second. Every second. 3 meters per second every second, or 3 meters per second squared. So that is, those are your givens, okay? The question says, how far does the car travel while stopping? A, that's delta x. And then the next question, how far? So how far, provided this doesn't turn around, how far is really a distance? But we don't have a distance equation up there. As long as it doesn't turn around, we can solve for how, and it's not going to. It's going to just go from 28 to 0 with uniform acceleration. Then we can just solve for delta x. That's really the only way to do this question. The next part says, how long does it take for the car to stop? That's t. I could do the second part first. There is no rule that says you have to do it in order. There's no rule that says you have to do it in order. I'm going to do it this way because I want to just point out that I can use the bottom equation. Why the bottom equation? I know the initial velocity, v sub 0. I know the final velocity, and I know the acceleration. I don't know the time. Again, I could go off and solve for the time. It's probably easier that way, but I just want to point out that you can use this equation. V squared equals v sub 0 squared plus 2a delta x. Let's put it on our numbers. V is 0. That's the velocity in the end, right? Which is 0. It stopped. That's v. V sub 0 is the velocity in the very beginning at 0 seconds. That's what that little sub 0 means. That's 28. Don't forget to square it. Plus 2 times negative 3 times delta x. You can notice I've written down my givens, I've written down my unknown, I've written down the raw equation, I plugged in the numbers. I don't need to put the units next to them. You can if you want to. I'm going to solve this equation. Show your steps. You can multiply that out to negative 6, but show your steps. Don't assume that you're doing it right and that someone, you have to be able to communicate this to me or to your employer or to your team members. And part of the communication, that's really what that's why the format's so important. It helps organize your work, for one thing. Actually, that's really important. And it also helps communicate what you're doing to others. Believe it, it's not all about you. I know, shock, ah! All right, you need to be able to communicate it to others. Okay, now we'll solve for this. 0, and the negatives are going to cancel out, which makes sense because it's moving in the positive direction. Positive 28 down to 0, it never turns around. It just slows down in the positive direction. Positive 28, positive direction. Let's see here. Negative, and then you square root of 28. That comes out to be 130. Meters. It's 130.666. I'm doing this to 2 significant digits. So that would be to 2 significant digits, it's 130 meters. When you're calculating, you should not round. You only round your final answer. So to do part B, we're looking for the time. There are a variety of ways to do this. How long does it take the car to stop? Probably the easiest way to do that is to just use this equation right here. Again, we could have done this first. V equals AT plus V naught. That's 0 equals -3 times T plus 28. So T equals 0 minus 28 all over 3. 2 significant digits, 2 significant digits. My answer will be good to 2 significant digits. And it's 9.3 seconds. Don't forget the units with your answers. You should never get a negative time value. If you do, you made a mistake. Time's always going to march forward in our class. All right? The end.